So today we're going to look at net displacement, total distance, and definite integrals using substitution. But I'm going to do one video on net displacement and total distance, and then the second video on definite integrals using substitution. So the notes are together this week. Okay? So interpreting an integral involving rectilinear motion. So the first example is an object in rectilinear motion is moving along a horizontal line with a velocity, v of t, equals 3t squared minus 18t plus 15 in meters per minute for the time 0 to 6. So t is greater than or equal to 0 and t is less than or equal to 6. So these are the two things we have to find. Okay? We're going to have to find the net displacement. Okay? Net displacement. So net displacement is just positives and negatives, and then we see how far away we are, right? We don't have to see the total distance that happened. It's just how far away we are from the start. So we want the net displacement from 0 to 6, and then interpret the result in the context, okay? So our net displacement, if it's ever asked for displacement, we literally just find the integral. So we're going to find the integral from 0 to 6, lower number on the bottom, higher number on top, of 3t squared minus 18t plus 15, d of t, or dt. Now the reason why we find the integral of this is if we want to find the displacement or the distance, we have to find the integral to find the original equation. So now this is just the same math as we've done before. So we just use the fundamental theorem of calculus. So what do? I say, okay, it's 3t squared. It's now going to be 3t cubed. Oops, that didn't work. 3t cubed divided by 3 minus 18t to the 1. It's now going to be t squared divided by 2. Plus 15, whenever you have a constant, it was 15t plus c from 0 to 6. And then we use the fundamental theorem of calculus. We plug the 6 in, minus plug the 0 in. But I'm going to reduce these first. And this becomes a 9. So what I'm going to actually get is 1t cubed, or just t cubed, minus 9t squared plus 15t plus c from 0 to 6. So I plug the 6 in first, and I'm going to get 6 cubed. That does not look like a cubed. I'm trying again. 6 cubed minus 9 times 6 squared plus 15 times 6 plus c minus, in bracket, 0 cubed minus 9 times 0 squared plus 15 times 0 plus c. Okay, so I'm going to get 6 cubed, which is 216, minus 324, which is 9 times 36, plus 15 times 6 is plus 90, minus c minus 0 plus 0 minus 0 minus c, and the c's cancel, and I'm left with negative 18. And what does that mean? That means I'm negative 18 meters from where I started. Okay? All right. So the net displacement is easy. Now, the total distance, remember distance, you count the positives, you count the negatives, and you add them all up. You don't actually take off that negative part. So on the previous question, we found the area under the curve of 3t squared minus 18t from 0 to 6, okay? So it would look something like 1, 2, 3, 4, 5, 6. So at 1 and at 5, if I factored this, Those are my x-intercepts of the graph of 3t squared. And then it does something like this. So that's just a quick sketch. So what we're trying to do when we're finding displacement is we're finding area under the curve from 0 to 6, right? So we take this area, add it to this area, add it to this area. So when we do total displacement, there's more area below the x-axis than above. So that's why we're getting this negative 18, right? That's total displacement. Total distance, we need to find all of the distance that it took us. We don't care if any of it was negative. We make it so it's not. So what we actually do is we go back to grade 11 and we use absolute value functions. So what did an absolute value do in grade 11? I'm going to pop ahead just a couple pages here so I can get a blank page so I can show you. So in grade 11, you would be given a linear function like this, let's say. And then we found that this was negative 3. When I told you to find the absolute value of that linear function, anything that was below actually was written above. So it ended up being like this, and this would go away. And that's how we get our absolute function. Okay, well, let's look at a quadratic. In this case, this big one. So we have a quadratic, 1, 2, 3, 4, 5, 6, has x-intercepts at 1 and at 5. So we have a graph that's doing something like this, let's say. Okay, and the equation was y equals 3t squared minus 18t plus 15. And you probably said to your teacher, okay, I don't know why this matters. Okay, I don't know why we have to find absolute values of graphs. Where are we ever going to use it? Well, right now, this is why they taught it to you in grade 11. That's why grade 11 20-1 is called pre-calculus, because everything you learn in 10, 11, and 12 pops up in calculus. Okay, so this is reflective of that graph. Well, if I want the absolute value of v of t, which is what we're going to need to find in this case, not just v of t, which was the integral, that was for displacement. Total distance, we have to do the absolute value of v of t. So any part of the graph that's below is actually going to be reflected above now. Okay, and this would go away. So we're actually going to count the area from 0 to 1, the area from 1 to 5, and the area from 5 to 6. But this is a piecewise function. Remember last year you had to write these as piecewise functions? So you are going to write the absolute value of v of t equals, well, this blue arm, which I'm going to make be green so you can see it now. These arms here, right? These arms are actually this equation, the 3t squared minus 18t. And remember, we're going from 0 to 6. So we don't care that the arms keep going on. We're only going from 0 to 6. So we know from 0 to 1, it follows the green arm, right? Which is this equation here. So my piecewise function is going to look like this. Oops, I'm missing the other line on my absolute. It should be like that. So my piecewise function is going to be 3t squared minus 18t plus 15 if 0 is less than or equal to t is less than or equal to 1. And that covers this arm over here. Okay? But we're going from 0 to 1 because that's where it hits the x-intercept. Our other piece is from 5 to 6 follows that arm. So that's going to be down here. I'm going to leave a space for the middle equation. So now I have 3t squared minus 18t plus 15 if 5 is less than or equal to t is less than or equal to 6. Now that middle piece, the pink function, is actually the green function reflected, right? In the x-axis. So if the green function is reflected in the x-axis, the pink function is the green function reflected in the x-axis, all it does is change the signs of this. So every single sign on there gets changed because if I reflect that in the x-axis, I get a negative in front, right? I get this. So my equation is actually going to be negative 3t squared plus 18t minus 15. So my middle function is going to be negative 3t squared plus 18t minus 15 if 1 is less than or equal to t is less than or equal to 5. So in order to do these equations, this is what I need. This is extremely important. If I get this, I can do the whole question. So what am I suggesting for you to do? Step 1, graph the graph. Step 2, make it an absolute value. So everything that's below becomes above. Step 3, write out your equations. So anything that was above stays what the equation was. Anything that now turned above gets reflected in the x-axis, so all of the signs change. And then you can write your piecewise function. So we're going to go back and redo that. So this is for total distance. So step 1, you're going to sketch the graph. So you need to find those x-intercepts, because the x-intercepts are very important. So our x-intercepts for this are 1 and 5, and we can factor to get the x-intercepts, right? And then we know we have a graph that looks like something like this. And then I stop at 0, and I stop at 6, because this is from 0 to 6. Now I know, I should have done it in green, just so we stuck with what I had before. So this is green, right? And it stops here, because I'm going from 0 to 6. Now what I know is, the pink reflects up, so it goes like this, right? So I know that this is gone now. So I'm going to write my piecewise function. So the absolute value of v of t, and we do this when we're looking for total distance. Displacement, we just do our lovely integral. Distance, we have to do the piecewise function, because it doesn't take into account any negative values, because distance is just how far away you ended up from the beginning. Displacement, if you started at your home and you walked all around town and you ended back at your home, you'd be 0 displacement. So you started at your home and you walked everywhere. You could have walked for hours and you end back at your home. You have a net displacement of 0. But the distance you walked on your pedometer or on your phone, if you were using like a run app, would tell you the total distance. So when we're asked for total distance, we have to look at all the positives. It doesn't matter that we started and ended in the same place. That's displacement. Distance is how long did I go? So in order to do that, you have to do your piecewise functions. So I do the green first. The ones that were above. The ones that were above follow the equation. So I go 3t squared minus 18t plus 15 if I'm from 0 to 1. And I always go from left to right. We did this all last year in grade 11. 0 is less than or equal to t is less than or equal to 1. And then I can do the other piece from 5 to 6, but I have to leave a space because we have to go from 0 all the way. Remember, that's how piecewise functions work. We did them at the beginning of the year. So the green arm also occurs from between 5 and 6 for your x. And then this middle pink one is this downwards piece. So all the signs change. Negative 3t squared plus 18t minus 15 if 1 is less than or equal to t is less than or equal to 5. So you need these x-intercepts in order to get these t values for your piecewise. Now all you have to do is you actually do integrals for each of these functions and add them up. Okay? So if I want to go from 0 to 6 for the absolute value of v of t, which I have to show this part, I'm actually going to do all of my pieces separately. So I'm going to go from 0 to 1 using 3t squared minus 18t plus 15 dt. And then I'm going to add to it the distance of the middle one from 1 to 5. And now I use negative 3t squared plus 18t. Oh, I'm in the dead zone on my iPad. 18t minus 15 dt. And then my green one again, plus 5 to 6. So you have to do this for distance. 3t squared minus 18t plus 15 dt should be beside my run out of room. And you have totally looked at distance and displacement before. I know you have. You do it in grade 10, in science 10. So now we literally have to do integral for that With the fundamental theorem of calculus, integral for that. Fundamental theorem of calculus, integral for that. So it's 3 big ones to do. So we're going to get 3, we did this already, but I'll show it again anyways. 3t cubed divided by 3 minus 18t squared goes up 1 divided by 2 plus 15t plus c from 0 to 6 plus negative 3t cubed divided by 3 plus 18t squared divided by 2 minus 15t plus c from 1 to 5. Plus 3 divided by 3t cubed minus 18 divided by 2t squared plus 15t plus c from 5 to 6. Now this is going to take me longer than one line, so oops, my line is going to carry on. Okay? So this is going to cancel and be a 1. This is going to cancel and be a 9. This is going to cancel and be a negative 1. This is going to cancel and be a positive 9. This is a negative 9 over here. 1 and then negative 9. Okay. And we just do our normal integral. So we're going to go t. Oops, it's not a t. We're going to do 6 cubed minus 9 times 6 squared plus 15 times 6 plus c minus 0 cubed. Oof, it's not like 3. Cubed minus 9 times 0 squared plus 15. Oh, this isn't 0 to 6, it's 1 to 0. Oh my goodness, Crystal. You're probably all freaking out right now. I need to erase this. This was from 1 to 0. 0 to 1, right? Silly Millie. Silly Billy me. Okay, it's from 0 to 1. Let's try this again. Sorry. So it's going to be 1 cubed minus 9 times 1 squared plus 15 times 1 plus c, because it was from 0 to 1, not 0 to 6, like a dummy, like I wrote it, so sorry. Okay, and then we get minus 0 cubed minus 9 times 0 squared plus 15 times 0 plus c plus, and then in the pink I would have, I fill in a 5 and then a 1. So I'm going to go negative 5 cubed, and the negative's outside, plus, and then I'd go 5 squared plus 9 times 5 squared minus 15 times 5 plus c. And I keep going minus, and I fill in a 1 now. Negative 1 cubed plus 9 times 1 squared minus 15 times 1 plus c. And I go back to the green. I'm doing from 6 to 5, so plus 6 cubed minus 9 times 6 squared plus 15 times 6 plus c minus to 5. 5 cubed minus 9 times 5 squared plus 15 times 5 plus c. So lots of work to be shown. So my c's, these green c's are going to cancel, these green c's are going to cancel because I'm going to end up minusing them. These pink c's are going to cancel. Okay. So my first green bracket, 1 times negative 9 plus 15 is 7, minus 0, 0, 0, so 0. And then I get plus negative 5 cubed 125 plus 9 times 25 minus 15 times 5 is 25. And then I get minus negative 1 cubed plus 9 times 1 times negative 15 is going to be a positive 7. And then 6 cubed minus 9 times 6 squared plus 15 times 6 is negative 18. And then negative times 5 cubed minus 9 times 5 squared plus 15 times 5 is positive 25. And when I add them all up, I get 46 meters. So what does that mean? Total distance from 0 is less than t is less than or equal to 6 is 46 meters. Okay, whereas the other ones were 18 away from their point because displacement gives you distance. So when you do distance away from start. So this one was 46 meters is the total distance that they went. And displacement, you can just use your regular old integral. So that's your first lesson.